I'm here with Bob Podolsky, and we're going to be talking about, he is a physicist and psychotherapist, 20 years of experience in both fields. And Bob is the founder of Titania. And Bob, we're going to be having several talks with Bob about science, psychology, physics, quantum mechanics. There's no telling where this could go.
All right.
But the conversation that we're going to have is on the scientific method and how the brain interacts with the quantum mechanical brain interacts with the quantum mechanical universe.
All right.
And so we're talking about the scientific method and how the difference between science and art, I guess, is how
That's where the conversation
started, and then we...
Yes. Okay. Backtrack a little so that people who watch this understand where this conversation began. It basically is a question of what is creativity.
Mm-hmm.
And some people think art is creativity but not science, and some people science is creativity, and some people think that writing is creativity. Well, they're all forms of creativity. Anytime new, true information is acquired, something creative has been done. So, art functions as a precursor, in many ways, to science, by which I mean that artists of all types, and I'm including visual artists, sculptors, writers, screenplay writers, movie makers, a lot of the work they do, in a sense, opens the minds of the people who observe the art in ways that lead to new science. So it's a very creative thing, art. Now, as for being creative in science, it's a little different. The scientist, the really creative scientists who not only manipulate existing scientific concepts, but who also create new scientific concepts, somehow they have to get that information, that new information, from somewhere. And the way it was explained to me, which I find highly credible, was explained by John David Garcia, who said, the brain is a quantum mechanical machine, and the universe is a quantum mechanical phenomenon. So, a really creative scientist, in some mystical way that we don't understand, reaches out into the universe, the quantum universe, with his quantum brain, and latches onto some new information, and brings it back. And that information, that's my bird, by the way, that information may or may not be true. It could be false information. So how do you tell true information from false information? Well, first of all, that is the sole purpose of science. Okay? Science exists not to create technology, not to help engineers out, not to create new gadgets, or the study of strange birds. No. Science exists to distinguish true information from false information. So how do you do that? Here's the rule of thumb. When you believe in order to, this is Gandhi, the cockatoo. Female. Very affectionate bird. Mm-hmm. Anyway, I was talking about true information and false information. And to explain that, I need to briefly explain intelligence. When I use the word intelligence, it means the ability to predict or control events in the real world. For instance, if I take a solid object and drop it, it's going to fall. Well, how far will it fall in a certain number of seconds? Well, I happen to have a formula that is part of physics that tells me how far it will fall. So when I let it go, I can predict. 3 seconds later, I'll know how far this thing has fallen. I'm predicting an event in the real world. And being able to predict it, sometimes I can control events in the real world. And that's intelligence, as I use the term.
So you would say intelligence is the ability to predict
and or control events in the real world.
That's your definition of intelligence.
I got that elsewhere,
Okay.
John David used that definition. My father, who was a physicist, used that definition. Now here's the tricky part. When you believe in the truth of true information, it increases your intelligence.
So when you believe in the truth
Of true information, it increases your intelligence.
Okay.
Believe in the truth of false information, it diminishes your intelligence. So, for example, if I believe the world is flat, I never learn to navigate around the world. But when I believe that the world is essentially a sphere, that helps me learn to navigate around the world. That, therefore, increases my intelligence.
Because you can get from here to there.
Exactly. And that's
Okay.
something that I can check on. It's objective.
Like a map.
Yeah. Yeah. Okay, so the role of science then is to do that. To ascertain what things increase our intelligence when we believe them to be true, and what things decrease our intelligence when we believe them to be true. When I was a child, there were still people on this planet, they were referred to as the flat earthers, people who believed that the spherical Earth was a hoax. Then came Sputnik and orbiting satellites, and suddenly you didn't hear much about flat earthers anymore.
So that was a conspiracy theory of your day, essentially.
In a sense.
I didn't think that was still the case at that point in time.
Well,
before
you
the Sputnik.
didn't realize how old I was.
No, I knew, but I didn't realize that was part, that there were actually people at that time who still believed the world was flat. That just seems quite bizarre.
Yeah, well, today it seems bizarre.
Okay.
But today a world without home computers is bizarre.
Okay.
But that was true then too.
Okay. I guess, it's just a paradigm shift of some kind.
There you go.
So ships being able to navigate around the world wasn't enough for these people. Actually having to have a device orbiting the Earth.
They thought that the stuff with the navigation was a hoax until they saw pictures of the planet taken from space. That shut them up.
Interesting, because back then they didn't even have GPS in ships and planes. They had to do everything by other methods.
Yes. In fact, one of my early physics career jobs was working for the Coast Guard, and they had a thing called LORAN-C, which was a long-range navigation system based on transmissions by huge towers that transmitted electronic signals. And so they built these towers 300, 600, 1,000 feet high, transmitted signals from multiple locations, and on a ship or a plane, you could receive these signals, measure the time intervals between them, and know, okay, according to these two stations, I'm somewhere on this line. According to these two stations, I'm somewhere on this line. Therefore, where they intersect must be where I am. And it was considered quite accurate if you could locate your position within a quarter of a mile.
Ah, okay. But those would only they wouldn't go out too far to the ocean, I'm guessing, because of the curvature of the Earth, right?
Well, they were low enough frequency that they could be used over pretty wide swaths of ocean.
Oh.
When there were transmitters on continental lands not far away. I mean, it was hundreds of miles.
Okay, but it wouldn't go out in the middle of the Pacific then?
Not in the middle. No.
Okay.
Anyway, so it was while I was working for the Coast Guard that they came up with the global positioning system using satellites. And that has become more and more and more accurate. And it's also used now, of course, by guided missiles, and the military version, which isn't available to civilians, but the military version of it is so accurate, they can put a missile through your window and not break the frame of the window. In other words, they're very, very accurate now, where it took a while for them to become that accurate. But as the technology advanced, the accuracy improved more and more and more. So now you could bury a dime in the ground and take the GPS coordinates of it, and if you went away for 20 years and came back, there'd be a very good chance you'd be able to find that dime with your GPS receiver.
Mm-hmm. The plates haven't moved, I guess.
I'm sure there are mitigating factors that
right.
could make it, that could screw you up. Always. Anyway, so that's how art creativity and science creativity are related. The important thing I would say to remember about that is that all the great scientists were also mystics.
Okay.
Not all mystics are scientific. Okay? There's quite a distinction between a mystical scientist and a scientific mystic.
Okay.
And the distinction is that the scientific mystic is a scientist first. And the mysticism is only involved in that he or she does something that they don't understand, that puts their brain in connection with that quantum mechanical universe, where essentially, if you believe that the universe is holographic, it means that all information is present out there somewhere. The trick is for you to engage your brain in such a way as to bring that information to you. Then, to see if it's true or false, you use science.
And so being able to repeat so in science, of course, it's important to be able to repeat your findings and have other people be able to repeat your findings. So that's part of that whole dynamic of being able to predict the
part of the method, part of the scientific method is you make a prediction, you perform an experiment, you get a result and compare it with what you predicted. There are very complex and elaborate ways by means of which you can estimate your accuracy of your prediction before you make the measurement. Then, when you get the measurement, you'll know whether or not it is within the range of admissible error that your original prediction permits. So I might say, well, okay, I can predict where that meteor is going to land within a 10-mile radius. If it falls outside that radius, the radius being my predicted range of error, then there's something significantly flawed with the prediction. If it falls within that radius, then I know that within my ability to predict, this thing came down where I said it would, not the exact point where it's going to hit, but within the margin of error built into my system, into my scientific prediction. And scientists know most of the time how much error there is in their predictive system. Learning that, figuring that out, is part of making the prediction. So I wouldn't predict, okay, a meteor is going to land on this spot. I'd say, well, it'll land within a certain distance of this spot based on what kind of tools I'm going to use to make the measurements, what kind of mathematical and physics tools I've used to make the prediction.
So now, if you have do a scientific experiment and it's outside of where you expect it to be, that doesn't necessarily mean you have a failed experiment. That just might mean you have more new information that you haven't taken into account.
Exactly.
And that's why I know I don't have the exact examples off the top of my head, but I do know there have been a lot of things that have been invented and created that were the results of mistakes or people.
A classic example is Madame Curie.
That might have been who it was.
Discovered radiation accidentally.
Okay.
She found blurred areas on a photographic plate that she couldn't account for. Well, it was a photographic plate. It was responding to something. And with some further experimentation, she figured out that there are certain elements that emit radiation.
Mm-hmm.
And all of the radiation physics that we've learned since then came from that discovery.